Alright, hello. Codeforces. Round 772. It is a Div 1. I mean, Div 2. But it is still rated for me. So I want to do well. So let me just open up all these problems and we can get started. Okay, given an array A size n, choose two different integers in order to break the array. This must be held. Or, okay, to not break the array. In order to not break the array, this do must be held. Print the minimum above any number of times in order to not break the array. So it's like we can just like remove like duplicates, I guess, right? I think it's just like we can flip the bit where it's like, okay, we'll replace AI with X and AJ with a Y. So keep everything the same. And we can use this bit above, and we can use that bit. Is it just the OR of the entire array? Okay, well that looks, well it passed samples. See if it's correct or not. Problem B, avoid local maximums. Okay, well we got A. Problem B. Given an array size n, each element of the array is between 1 and 10 to the power 9, perform several operations. You can replace an element in the array with any integer. Okay. Output the minimum operation using a resulting array doesn't contain any local maximums, as well as a resulting array. An element A at I is a local maximum if it is strictly larger than both of its neighbors. So you need to make sure that the resulting array doesn't contain local maximums. And we print the result afterwards. Oh, but like local maximums are like strict maximums. Okay. Huh. I think we should just keep track of all the local maximums. Now if you start from the leftmost local maximum, if it's well, local maximums can never be adjacent to each other. It's like there's always going to be some sort of gap. So if we have a gap, let's like this, at like this, then this, then the best operation is to increase that middle one to the maximum of its two neighbors. Yeah. Otherwise, if it's like this and then like two numbers and then like this, instead of increasing these two numbers, we just bring those two down. Okay, I think that works. Let's try this. Array list. If array at I minus 1 is this, and array at I is strictly greater than this, then we add in this index. 4 and yeah, so it's basically just like for this and then this. If if they're 2 apart, and like this could match in the future. So we just like move on, otherwise we like so essentially while occur is less than ls.size. And if cur is less than ls, okay, well if cur is equal to ls.size, then we just have to set that one to a neighbor. Otherwise, we need to check if dex plus, I mean, it can never be +1, but it could be +2 if it's equal to this. Yeah, essentially we just like move on as well, but we always use like 1 in every step. Oh, we have to print that resulting array as well. Okay, wait, let me just first see if it's like the number of operations is correct or not. 0, 1, 1, 2, 2. Okay, number of operations is correct. Okay, well, if cur is equal to ls.size, then it's literally just array. We could just do array of 1. But we don't want to make any of its neighbors a local maximum, so it's like if we do smaller one, that one might be a local maximum. So we want to set it to the biggest one. So it's like array of dex becomes a max. Yeah, it becomes this. Okay, so if it's like, if we can only turn on 1, then this operation stays the same. But this is a little different because then it's max array of dex and then array of dex plus 2. Okay. And then we do, oh, we have to output this array. Okay. Okay, it looks legit. Problem B. Oh shit, wrong answer, test case 1. Okay, let me just go in Codeforces just to get the actual verdict itself. The number of replaced positions doesn't match your answer. Oh, I'm stupid. I can just do, I need to do that. No, problem B. Okay, we got B. It was just a silly bug. Okay, given an array A of n elements, you can perform the following operation no more than n times. Like 3 indices and replace, select 3 indices and select the leftmost one with the difference of the values on here to here. And on top of this, absolute value of ax must be less than 10 to the 18. Goal is to make the array non-decreasing. It's weakly increasing. 432 is apparently impossible. Or I guess it's always impossible. It's always impossible if those 2 elements aren't like good. Okay, the only way we can change the 3rd element is to use the second to last element and the last element. So if that's not good, then like that's like unlucky. Oh, okay, but we can't make it exceed 10 to the 18. Oh, it needs to be less than 10 to the 18. Oh, but the thing is, we can make it non-decreasing, though. We don't have... Do we have to minimize? Okay, we don't have to minimize. So I think it's pretty easy then, because if the second to last element is strictly greater than the last, then no matter what, it's impossible. Otherwise, we want to look at... I mean, if it's already, like, less than it, that's okay. We want to look at the first element such that this rule is, like, broken. So that it's not, like, consistent with it being non-decreasing. And we want to find the minimum here and maximum here. If that works, then we could just do that and, like, do it for the rest of them. Okay, yeah. Let's do this. So we've got T... Okay, so we've got N and then array. Oh wait, less than 10 to the 18. Wait, I just came up with a way to do it like with less than 2 times 10 to the 9 then. Well, yeah, I mean, I guess it's fine. Yeah, because then it's like, it's non-decreasing. There's a reason why they probably bolded that, because it makes it a lot harder if it had to be strictly increasing. And this number could be like the smallest one, or like tied for the smallest one. You can like use that same like operation for everything. The thing is, like, if it's always possible, then we use the same operation no matter what. Okay. So just N and then array. Yeah, so if array at N minus... Okay, N is at least 3, so we can do this. N minus 2 is strictly greater than N minus 1. Then it's never possible to make this non-decreasing. Okay, and so min... Okay, well... min loc is equal to N minus 1. Okay, so like the location of the minimum and location of the maximum. And then if array at N minus 2. Oh yeah, because we know like array at N minus 2 has to be less than or equal to N minus 1, so minimum location is such. Okay. N minus 3, I is greater than or equal to 0. If basically if array at I is strictly greater than array at I minus 1 or I plus 1, then we want to check this if this operation will work or not. So if array at min location, oh wait, but y has to be less than z. I mean, it's obvious that we can't like do it by itself. Yeah. But like if some maximum occurs, like that minimum can't be. Okay, I think it's probably the hardest part about this problem then. Even though we could just use suffix max though. We really just say if this is like a fixed minimum element. Like if we choose y, then like we just want to choose a maximum in its like suffix. Yeah, okay. Let's just do that. We do suffix, I guess suffix maximums, or like where the maximum is located in particular. So if I is equal to okay, so if array at I, okay, I'll assume this, but if array at I, I'm going to do the maximum if it's less than or equal to array at suffix at I plus 1, then suffix at I becomes suffix at I plus 1. So this should tell us where the maximum is located in the suffix. Okay, so after we know where a maximum is located in a suffix, okay, I'll rephrase these to y and z. Okay, so, well, I guess y, or like which one is like the best location. So we want to check if, you want to check to see if array, or I guess array at y minus array at, or I guess like that suffix maximum plus 1, yeah, like suffix at, because this is an index. So like everything after this index. So if this difference is strictly greater than array at I minus array at suffix at I plus 1, or it's like this element and then the maximum one here, then y becomes I. Okay, then if array at this is like the best, like the smallest possible value we can get, like using an operation here. So if we use this operation, but even after using this operation, we don't get the fact that, or like we don't, I think we can replace this value, but it's still less than it. Or it's still less, yeah. Then it's impossible. In which case we can just do continue test case, yeah. Else, okay, so if everything was like this, then we could just do, yeah. Otherwise, we could do, an x would just be equal to I, and then an z would just be equal to suffix at I plus 1. And we just repeat like this operation. For in a is equal to I. I guess while x is greater than or equal to 0, we just do, I guess I plus 1 removes. We can do sp dot append. I guess just x plus 1. Okay. So let's see if this is consistent with what we have over here or not. Some operations -1 and 2. I mean, as long as the operations isn't n, or like doesn't exceed n, then it's fine. Okay, so pretest 5. Okay, we got C. Okay, so you have these problems, I guess. Alright, you're given an array A consisting of n distinct positive integers. Let's consider an infinite integer set S which contains all integers x that satisfy at least one of these conditions. Find the number of elements in general strictly smaller than this. Consider an infinite set S which contains all the integers that satisfy at least one of these conditions. Okay, where x's of element in this array could either be 2y plus 1 or 4y. So strictly smaller than 2 to the power of p. The number of elements are strictly smaller. So if it's like this and then this, I'll read both problems. N cars move in a coordinate axis like this. Each car is located in a point. Initially, no two cars are located at the same point. On top of this, each car is oriented either left or right, and they can move at any constant positive speed in that direction at any moment. Orientation is location. They never end up at the same point regardless. Always end up. Restore the orientation and location of the car, satisfying the they will intersect at the same moment. They will continue their movements in their direction. Oh, that's interesting. Wait, that's interesting. So it's like more formally, we can describe the ith card of the letter. I want to rephrase this as that if two cards are irrelevant, let's assume the ith card is located somewhere like less than or equal to it. That's interesting. I'm going to ask a clarification. Two cars destined if they start at the same position. Okay. Seems interesting though. Also, why is this loading? Taking so long to load. And weight point, so coordinate. The weight between this is defined as this. And the minimum weighted distance among all pairs at distinct points among all points in a subarray. The minimum weighted distance among all pairs of distinct. The coordinate and weight of the ice point is this. Okay, this holds. Okay. 300,000 to the power of 1.5. Is that viable at all? Why is everything taking so long to load? That's actually kind of viable because of 3-second time limit. Okay, but like if we make one update. Okay, yes, it is. Cool. Is there a way we can make an update in here if we already know some information? Well, we have some x at j. so then it's like xi times this minus this. Okay, so if we assume I is less than j. Wait, I guess I is strictly greater than j. Then it's like this times this. It's like this plus this. Minus this plus this. That's something I don't know how. Okay. Okay, so we read all the problems. I don't know why I just closed that. I'll think about D first a little bit more. If it's strictly small and 2 to the power of p. I guess, how can we tell if a number is in the same, like, class, I guess? Or, okay, wait, if we had something that was, like, from x to 4x to 8x plus 1 to 16x plus 2 versus we had x, we could have 2x plus 1 and then like times 4 is 8x plus 2. Or I guess like where this number like pops up doesn't really matter. Okay, like for example, if it's 2, then it goes like 2 times 2 plus 1, which is 5. It goes 2, it goes to 5. 2 times 2 plus 1, and then it goes to 11. 2 times 2 plus 1 goes to 20, I guess 23. And then 46, 47. I guess something like that. X to x is basically what's happening. Then it's like 4x plus 2, then 8x plus 4. Yeah, so if it's like minus 1, minus 2. Or I guess 4x plus 3 actually. And we multiply by this. I guess it gets multiplied by 2. It's like 1, 3, 7. 7, 14, 15. 15, like 31. I guess stuff like that. Yeah. Huh. The second example. Okay, well obviously if some number is bigger than that, then we don't give a shit about it. If the value is small, okay. What's special about this these numbers? 2y plus 1 and 4y. These elements are smaller than this are these. So wait, it does seem like we could get a lot of elements even just from 2. But 5 and 20 are in the same like class. Okay, 4x plus 3. 4x plus 3 could also turn into 16x plus, I guess, 12. Which could then turn into 32x plus 25, which in turn could then go to, we multiply that for 120x plus 100. Wait, it's not very obvious as to how this changes, I guess. Oh, if you think about it in bit form, either it gets shifted to the right and the last digit becomes 1, or it gets shifted twice to the right. Okay, I think it's pretty easy to like eliminate like the same element like within here, because then we could just basically check. And like there's only, this will increase by either 2 or 4. So let's assume that every element here is like kind of in its own group. Is it possible for 2 different numbers to like not end up merging in the same group? I say if 2 different numbers, then what would happen is say we had like a number, this was one number and this was like another number. Okay, well if they didn't end with like 4x operation, okay, so they either had to like end in this, because these are different parities, so if they were the same number, they had to end in the same operation. But then it implies they were the same number for that operation. Okay, so that means, okay, this means that 2 numbers from the very beginning, they'll never overlap. Okay, that's good to know. So, oh, please let me code. So if x is not equal to y, then descendants of x will not overlap with descendants of y. Okay, that is good to know. Okay. Yeah, so if we start with a list of like all valid descendants, then can we just BFS? Okay, let's say we started at 1. If we started at 1, like some value, it's like, okay, 1 can either go to multiply by 2 and add 1, so it's either 3, or just straight multiply by 4, so it's either 3 or 4. 3 multiplied by 2 plus 1 can either go to 7, or just multiply by 4 to get 12. Or we get either 9, or just multiply by 4 to get 16. 7 can be either 15 or 28. 12 can either be 25 or, I guess multiply by 4 is 48. 9 can either be 19 or 36. 16 be 33 or 64. Yeah, but these numbers will never like overlap with each other. Yeah, okay, so for example, if we only consider numbers that are like from, because we know these numbers never overlap with each other, like that's not necessarily possible. Okay. Okay, well the thing is like, so there's never like any overlap in this like tree. But every number will like spawn 2 new numbers. Or is there overlap? Well, okay, if they end up being the same number, then like they had to be like the same number every single step. So no, it is not possible. It's like the moment like a number turns different, then like that's bad. Okay, it's strictly smaller than 2 to the power of p. So I think we just want to find elements. We only care about the most significant digit. I think we only care about the most significant digit. And I mean, I guess no, addition actually doesn't even change it though. It's just like we either shift the digit over by 1 or we shift the digit over by 2. Okay. So either sub. Okay, if you start off 1, then like the parity can either change by like doing plus. Okay, so like +1. It essentially could change to a +4, or you could essentially change to a +3. Because 1 gets multiplied by 2, and then we add another 1. Multiply 2 plus 1 is like 6 plus 7, which is just +3. Or just multiply by 4, it's just like, obviously this is 0. And like when it's 0, it's just like whatever. And then if like +4 plus 4 is the same as just like +0, so like multiplying itself, so it's like +1, or we get plus 0. So like 1, 0, 3 are the only like reachable ones. And once it becomes 0, it can never. I guess it can always be like that. Okay, so maybe it's like for each smallest number, we just check every power of 2, I guess. It's kind of whack. I know we can't BFS like this easily because it's just like each layer will duplicate by 2. And so it's like, but actually can we? Hold on, because then it's like there will be log 10 to the 9 layers. Each layer will have double the number from the previous layer. Yeah, it's like 2 to the power of 4, 2 to the power of 1, 2, 3, 4, 2 to the power of 8, like 2 cubed. And so we'll keep on going up until it essentially reaches 10 to the 9, which is like 2 to the power of 30. Yeah, okay, no, I don't think I'll work. Yeah, no, there's just too many like new things in there. Okay, but let's assume like all of these numbers are like non-overlapping. I think we can do some sort of DP, where it's like the DP of, we only care about the most significant digit. Where it's just like, if this number is like the most significant digit, then the number of like ways it works is like, the number of ways we can either do like 2 significant digits or 1 significant digit. There's just stuff like that, yeah. Okay, so, or most significant bit, I mean. How to determine because we need to remove all of these values. And then once we figure out how to do that, then we have a solution. I'm gonna go to the bathroom. Okay, how do we determine if two numbers are in the same like class then? Obviously, if it's the same power of 4, it's in the same class. Wait, are there only 2 classes? Like, if it's 2... then it's 5... Okay, or 8. 1, 2, 3, 4, 5. Oh, yes, 6 isn't anywhere to be seen. Yeah, because 6 is an even number not divisible by whatever. Okay, so it's not like very like obvious, because then it's like 11 or 20. Yeah, it just spreads out too much. If it spreads out a lot, though. Maybe we start from a big number and like divide it and see if it has a number containing in it previously. And if it does, we can remove the bigger number. Because if we remove the bigger number, then like that gets rid of like that dp that we're calculating. So oh wait, I guess we know. Yeah, because if it's odd, then like we know we just did this move. It's even, then we just did that move. Oh wait, okay. Yeah. Okay, I think that's it then. I think this is, I have a solution. This is, yeah, because we just go backwards and then we just like find that value, and because we at least divide by 2 every time, it's log n. Find extent log mod is equal to I'll use fast scanner just because this is like n times log of 10 to the 9. So it's not like, so it's not like, it could be a little bit tight depending on the documentation. Okay, so now we need to like figure out how to write the dp. Or is this like, what is the contribution of this? So it's like dp where it's like this element appears. Or like if this element appears. Okay, so for example, how many elements of, okay, so if one element of dp of this appears, yeah, so then it's just like either okay, so it's like dp of some number that's equal to this like bit. How much does this contribute? Is equal to 2 to the power of k. so if it's like 1, 0, 0, then it's like dp at 2. Like dp at 2, obviously, okay, so if k is, like greater than or equal to p, then dp at k is equal to 0, because then it doesn't contribute anything. Otherwise, it can contribute, well, it contributes itself plus whatever contribution it gets from here. Okay. Alright, sounds good. We can just do long dp is equal to new long at, I guess p plus 1, I don't know. So I guess I can do p plus 3, and then it's like, yeah, I want to start at p minus 1. So dp at k is equal to dp at k plus 1 plus dp at k plus 2. And if dp at k is this, then we do the same thing up here. Yeah, because then it's like 1 plus that. Okay, so we already read in the array, so then we can use a, okay. So I'll do this. Min is equal to min of minimum itself in x. Okay, so we do this, and then we do if so we do something while this, public static in parent in x, if x, otherwise we return x over 4. Okay, so int val is equal to parent of this, and so while true if or I guess while the value is at least as big as our minimum, so that contains val, then we know like it's not a unique class, in which case we can do added I is equal to false, and then continue, or I guess break. Otherwise we do val is equal to parent of val. And then if it goes all the way here, then like we know that it's like not. Okay. Okay, so if we add I, then b is equal to int bit is equal to 0, or int b is less than 30. If array at I and one method that b is greater than 0, bit is greater than b. I guess b is equal to 29, b is greater than or equal to 0. And we can just break and just save a few iterations. dp at bit, if des is greater than or equal to mod, let's give this a shot. 2, 4, 6, 1. Okay. 14 and okay. My submissions. I'm gonna wait on this one. Don't TLE. I'll be kind of annoying if it'll be annoying if it TL. Run. Okay, what the fuck? Like runtime error. Oh wait, what? Hold on. If it's equal to 0, if it's equal to 1, that's the first mistake I saw. Yeah, because like if it's an odd number, then like its previous element was like it divided by 2. I don't know if that'd be enough to runtime error though. I mean, the answers are still the same, which is low-key kind of surprising. I'm not. Oh wait, no, they're not. Okay. If x and 1 is equal to 1, so if it's odd, then we divide by 2. Oh, but 1 and 6 are not reachable. Oh, we're accidentally dividing by 4 when it's not possible. Okay, well, if it's an odd number, if x is equal to 1, then it obviously doesn't. If x is odd, then it does. Otherwise, it depends on whether it's divisible by 4 or not. Because if it is divisible by 4, then it has a parent. If this doesn't have a parent, then we just continue, because we know like it has to be its own thing. Otherwise, we get the parent, and then if parent exists, then we do this. Okay, so if value doesn't have a par, has a parent, then we break. Otherwise, we get the parent, and then we move on. Maybe the runtime error is from there then. Okay, well, 9, 14. Yeah, maybe runtime errors, it's like it keeps on, it like divides. Right, because when it's on 1, like, and it could break, I guess. Okay, this DP has no problem whatsoever. It's not like memory. No, it's not memory. Yeah, so this DP should be fine. You just get the minimum of value and throw everything into a set. That's okay. If has par, this is just a function, and either returns x over 2 or x over 4. Okay. And if all the mins are 1, okay, I'm gonna just resubmit and see if it helps or not. I'm not even really sure what that runtime error could be. Okay, we're still getting that runtime error apparently. Yeah, we're still getting it. Okay. Could it be long overflow? No, I don't think so. Okay, this should be okay. Oh, I know what's happening. Oh, I know what's happening. I'm very stupid. If bit is less than or equal to, right? Yeah. You only want to add it if it's less than p, because if it's equal to p, then it doesn't make sense. Yeah, okay, I think that's the reason why. Yeah, because if we didn't have it, like, that could have been out of bounds. Let me just make sure that this is, it should be okay. It's just like, because it would have just added 0 anyway, yeah. Okay, but that might be why, because it's like index out of bounds. Okay, pass pretest 4. Okay, we got D. Okay, ran decently fast. Yeah, I just had a very stupid bug, honestly. Alright, so that's problem D. Let's move on to E. Oh, right, cars. Okay. Orientation is left, then orientation is L, otherwise orientation is R. Okay, what does that mean? What does this mean? Orientation is like here versus here. Okay, but we can't put xi on this same location. Okay. Okay, well, same movement will continue moving in that direction. Okay, so two cars are destined if and only if this is left and right. No, if it's like left and right. And they're irrelevant if they're left and right like this. Huh. Okay, so if car A is irrelevant to car B. Okay, can A be irrelevant? Let's assume A is irrelevant to B and also A is irrelevant to C. Can B and C be irrelevant? So if this is car A, right, then car B has to do this. Car C. Is there an explanation or not? Okay, car 1 is at R0. Is equal to n is equal to x int. Okay, so is type and then the two things. Okay. Okay, so static final cons is equal to, okay, if it's 10 to the 5. Public static long get int a and b. Turn min at a and b times cons plus max at a and b. Yeah, we'll just do that. Hash map long integer. Hash map long integer. We have about 46 minutes. I think I can do some 46 minutes. And then, okay, we're reading the m edges, so while. Yeah, we don't need the access to what kind of edge it is originally. So static array like editor edges. Do edges is equal to new int n plus 1. Edges at I is equal to new array tag at editor. Perfect. And so we can do type is equal to get this and I and then j. Okay, so we do these, and then we can do if and only if it's give it back to public static boolean type. The only thing we start off with is the end because we have access to all the edges in there. So yeah. Arrays that fill color -1. Q.add while q.size is greater than 0. Color at next. What occurs or one q.add next. Then return false. Okay, so we've checked to see if it's bipartite or not. Otherwise, we assume the answer is always yes. Right. So the answer is always yes, no. What do we do? The answer is always yes. I guess we create units. Yeah. And ID public setting a color is equal to new integer then. Okay, so now we have access to color, which is good. We have ID public. Okay, so ID is equal to A, direction is equal to D. Left is 0, right is 1. Actually, I guess we could just implement this in place, right? Comparable. Okay, so we only really care. We should only make comparisons that are relevant if they are different directions. So if direction is equal, then we just return 0. We assume they're the same. Otherwise, if there exists a relationship. Oh, okay. I guess we can't implement it in here then. Okay, I'll do this then. Just trying to think of the best way to implement this such that it's like neat. We have a color. We also need to access whether an edge exists or not. Okay, yeah, so we don't want to do it out here probably. Alright, that should be, there we go. Because everything in here is 1 indexed. So we do, right? We do the scene at root. Okay, well, scene at root, and we just move on. Otherwise, we do or not unit, but car. New car, we got an ID and a direction. So this is the ID. This is a direction. So if we haven't seen the next thing, then see next, Q dot add next. ls xy. So if next direction is equal to 1, we just return 0. If not contains key. Then we return 0. Oh, get. And type is equal to map.get. Okay, so long key is equal to get. Oh, we already did the min thing, yeah, internally. Yeah, so we don't have to worry about that. So if it doesn't contain key, then we don't care about this relationship, so just say it's 0. Otherwise, if x.direction is res is equal to 1, if x.direction, because we want to assume that assume it's L, so let's assume it's at 0. So if it's equal to 1, then we're just multiply by -1. And then if edge type is equal to, oh, type 1 and 2, okay. So if the type is equal to 1, then we want to return -1. Or return res times -1. Oh, I return res. It's like this edge's type is this. Okay, so that's our sorting function. And then we just like put everything in order, I guess, right? And so we do for int I, or I guess if we do or car C in this list, if C at direction is equal to L, then res D at C dot ID will be equal to L. Well, if C at direction is equal to 0. Otherwise, yeah, because that's like L and then R. And then we do res x at C dot ID is equal to this. Okay. I'm going to move this up here, or I guess from here to here. Wait, what do we? Okay, just res D at res x at C. Well, if that's not right, then it'll just tell me it's not right. Okay, let's see. Oh, okay. Restriction 2 is not satisfied. Okay. Oh, I guess in the sorting function it doesn't hit everything. Okay, yeah, I'm stupid. We can do top sort. Okay, yeah, I think we do top sort instead. Yeah. Well, because we can get like all information about the cars. The idea is like between every edge that this car is involved with. I'm gonna find the direction of this edge, and then we just top sort it. Yeah, okay. Okay, I think top sort is better. Yeah, we have, how much time do we have to do this? 32 minutes, that should for sure be enough time. Yeah, okay, this is just like getting every like, I guess this is hitting every edge. Where it's like, okay. Okay, so then we do for int for this integer, this array, we're not, I guess, okay, so for every car, we want to add some sort of edge to it. For car C, LS. Not even every card is for, yeah, and v is equal to c dot id. So that's where it like kind of starts. So if we only want to consider edges in one direction, so let's just say if color v is equal to 0. So if this is a node that faces to the left, that would do something right here. So like if this node faces to the left, we can do like for next edges at v. Because like this one has to face right. So it's like, and type is equal to get v and then next. So, or I guess long. So if map.get type or key, this is what the type is equal to. So if the type is, for example, equal to 1, then that means v has to go before next. Okay, if it's equal to 1, then edges top at v dot add next plus edges top at next dot add v. So we do something like this. What is the type of top sort we do? Or like, what are we even doing here? I feel like we do DFS and we add something into here, then we reverse it. I don't think that's ever possible because it's bipartite. I take that back. If we have something that's like this goes here, because the tree is always bipartite, we could start off doing something like something has a relationship where it's like these have to go over here, but then all of a sudden it's like, oh, but like they can't share a relationship either. And like because they can only be connected with like two of the same color. I guess okay, maybe like D and C have a relationship where it's like D, okay, so it implies, but there's no like definitive like, even if there's like some intermediate conflict where it's like C has to go to D, yet for some reason there exists a node such that, or exists some sequence of nodes such that this has to go over here no matter what, where in the sense that this has to go over, D has to go before here. And then this goes to Y, but then C has to go after this. Oh, I guess this is bipartite. So if a top sort doesn't exist, then it's not possible either. Okay. Yeah, cards, like whatever. Then we do the top sort, where it's so we do static boolean C in a top sort, where we can do this is the array that we use for our top sort bullshit, where we do 4 cars C. And so if we haven't seen, okay, if this holds true, then we can do something like I don't want to use cards here, I just want to use integers. Yeah, that way it's like int v ls. And then if this color holds true, then we can do this int v and ls, and then curse d and order. Okay, so if we haven't seen this, then we do do DFS from V. Collection stop reverse. Or no. New array list dot car C in order. Not order, but temp. I mean, that just would have visited it in a DFS anyway, yeah. So public static, public static void DFS in array list. Scene TS occurs curve point next and edges top at curve. Not scene TS next, then we DFS to next and LS. Otherwise we new car color at curve. Right? That's how we did it. Yeah. So we did a top sort and then verify top sort exists. If we're in next, long key is equal to get via next, and so if if map.getKey okay, well I guess we only want to do this if color of V is equal to 0. Wait, maybe you just do order.add. Wait, is that how it works? Where it's like, yeah, because like if we visited this, then it's like we add this and this, and then we have to do this, and then we add that. Yeah, so it's like ABC. Wait, it gets CB, but we don't want to reverse BCA because I guess that's not valid. And reverse it again, ACB. No, we want to just keep it as A and then reverse it to the end. Okay, so let's DFS at order. DFS V in order. Collections sort order. And by sort I mean reverse. Int for int I is equal to 0, I is less than order dot. So we do TS location, top sort location at order dot get. I guess like this dot ID, or like this is like the node itself. And verify that the top sort exists. And so if map.getKey is equal to 1. Okay, so if it's type 1, then it should be like left in here. And so it has to be less than, so if it's greater than, then we have a problem. Okay, same thing up here. 10. Pretest 11. Okay, I'm gonna see if I can speed this up if I need to. Hopefully I don't need to. So far it seems pretty good. Pretest 14. Wonder how many pretests there are. Nice, crashed. Okay, let me just check my submissions page from here. 1247. Huh. I think I'll be okay. It's a 2-second time limit. I think I'll be fine. Yeah, I think a time limit will be okay. Let's just see if there's anything I could fix if I need to. I guess I could reduce like the number of times I like do hash map bullshit. No, I think I'm good the way it is. I think it's fine. I think I'll be fine. Like, 800 milliseconds is enough of a margin anyway. Okay, that's basically my contest then. Let me just check to see if there's anything to hack. Nope. Oh, at least nothing has been hacked yet. Cool. Cool. Currently 59th place. What problem? Okay, A is probably not hackable. B, maybe, but also I feel like if there weren't hacks yet, then they probably had really strong test cases. C is probably not hackable. D is not because it's DP, or at least probably not. E is well, I just did E. I don't think it's hackable. Or at least I'm yeah, it's fine. Okay, that is a contest. So I will try to hack, but I'm just trying to think what problem could I even try hacking. Okay. Wait, how about memory? Okay, they gave us more memory on purpose. That's good. Oh, okay, that's before. It hasn't updated yet. Probably not. Okay, we'll see. Go with B. Okay, I'll lock A just because it's such a simple solution. Let me just make sure that the bounds are okay. It's bounded by 2 times whatever it is. If it's 10 to the 9, it'll be fine. Yeah, it's just like all the bits. Yeah, that's fine. Yeah, but brute force solution. C is equal to A. Oh, okay, I see. Yeah, that's fine. If this and we set count equal to 1, if the bit is, okay, so that's just a more complicated way of implementing it, but it's still correct. Wait, what? Wait, hold on. If the and is equal to the or, so if the XOR is 0, okay. So if they have no like different bits, wait, if they're just the same, I don't understand how the solution is working. Hold on. Let me see if I can actually hack this or not. 635A hack. If we do something like and n is equal to 10. What are the exact constraints? Okay, it can be 0. Bit times 16. The smaller numbers, I guess. Then we can do what is A? Oh, A is size. That's so weird. I plus 1, J is a set n. Okay, if array at I and array at J was equal to array at I or array at J. If array at I is greater than or equal to array at J, then array at I is equal to array at I minus else we do array at J is equal to array at J minus array at I and array at J. And at the very end, what do we do? For an X in an array, the sum of this is the answer, according to you. Can I do a smaller array just so I can like make sure? Lol. Okay, so my solution is probably right. I hope it's right. Let me just run it really quickly. 1, Okay, so the answer for this is 15. Like 15 to 31. I need to double check just to make sure this is like actually like hack. If this is an actual hack, or if I just implemented something wrong. Okay, so we do this. Solve and an array. Whoops. Okay, I implemented something wrong. Alright, what did I implement wrong? We subtract the same bits off of each other. Wait, I don't see what's wrong with this. Like, what's inconsistent? Because it's obviously, like, not right. Like, well, it's not right with the sample. At least I don't think it is. Wait, what's going on here then? The dude is named Conga X. Maybe it's the fact that he didn't have any parentheses here. But like, that's not even a valid statement. And an array. Wait, what it might be? It might mean this. No, but like 1 bar is like bitwise. These are all bitwise operations. It's like it has to be this, right? I'm very confused right now. So we do this. Okay, so if array at I and array at j is equal to array at I or array at j. So if a bit exists in a number, it has to exist in another number. If bit doesn't exist in one number, it can't exist in another number either. That's basically what it's saying. Well, they have to be equal, but like that's obviously not true. I'm just a little confused right now. The C++ syntax is different in this regard. this is greater, then we take whatever the and of this is, and we subtract it off of array at I. Okay, that's a thing. But it's still not right, though. That's the weird thing. It's still not even correct on sample. I need to at least get a work on sample. Maybe he's trying to say, if array at I and array at J. I'm so confused right now. Like, why does this even, how does this even work? What if I just do this? 33167. Oh, it might literally just mean it. It's just okay. So true. I have a feeling this is always true. It's supposed to be true. Sad. Okay. It's probably fine then. Yeah, that would have been impressive if he somehow got that. Like, not, you know. This is the same thing as happening here. So if I doesn't equal to J, then okay, then we do C is equal to array at I or array at J. Array at I plus array at J, and we do some bullshit. If array at I is strictly greater than array at J, array at J is or array at I. Array at I, array at J became 0. Okay, it's still sad. Yeah, it's probably fine. This is a very convoluted way, but it's probably okay. Alright, that's my contest. I don't think I'm getting any better than this. I'm 61st right now. Hopefully no FST. But yeah, that is it. Let's check what my predicted rating is really quickly. Yeah, but aside from that, not many people on my friends list competed today. A plus 85. Okay, it's plus 85. Hopefully that comes true. I don't mind that.